Hey everybody, hope you're all doing really good. So today I'm going to be working on an iPhone SE 3rd generation, I believe, that was sent here after a botched screen replacement. The phone is able to power on but gets no image on the screen, and we're going to have a look at it today. So here's what this phone looks like. This was actually received without the screen on it, and it already has a gasket installed on the outside of it. The damage that I'm seeing is actually down here by the display connector. It's going to be very, very difficult to see it without a microscope. Now, looking at this area under the microscope, we can see that there is definitely something missing right there. We have a capacitor here, but then there should also be something right here, and it's not there at all. It's just totally, completely gone. So having a look at the board view for the SE 2022 3rd edition, we can see that this component here is the one that is missing. We have the capacitor here in place, and then this component here is just totally gone. Now, I don't have a board view that has the proper lines labeled on this newer 2023 model phone, but we can look and see what pin on the connector it is hooked to. So this is supposed to be hooking some signal that starts here, and it's actually coming from the bottom of the board, from this IC and these 3 caps here. So we've got a switching power supply here that's putting out some power, and that's supposed to be coming over here to this side of the board, into this side of the inductor, and then out of there in the display connector. Now, I'd be quick to say that that's a 1.8 volt line that's missing, except it's coming directly out of the side of what's going to be like a switching power supply. So we actually can't use this board view here to tell exactly which line is missing, but we can have a look at an iPhone 8 that is very similar. So let's just load up an iPhone 8 board here and see what that's showing. We can zoom in and pick the same exact pin on the connector, which was this pin right here. Oh, and look here, we got FL5700, which is PP5V7 underscore display underscore AVDDH underscore con. So what that means is that our iPhone SE is missing a 5V7 line going to the display connector, most likely. And it also means that our missing component is actually FL5700. So we're going to need that back in place in order to get an image on the screen. Let's fix it. So looking much closer at this, we can see that this side where our missing component is has nothing left other than just the side of this capacitor. And then the other side of here, we've got this teeny tiny little nub visible right there in the center. So we can either run a wire all the way from the other side of the board where the power is coming out of the power supply, or we can attempt to solder to this tiny little nub, which is most likely what I'm going to do. I want to find out, and I want to make absolutely sure that we have continuity between that capacitor and the connector. And to do that, I'm going to use a multimeter and just make certain that these things are connected. I'm going to use beep mode. There we go. All right, so we do have good continuity there. All right, so let's begin getting this fixed up. I'm going to take my blade and see what sort of a prospect we have here to solder to. I would like to do this without running a wire all the way to the other side of the board. So let's just get down in here real close and see what this little nub's going to look like. And if you're wondering just how big this is the tip of a number 11 X-Acto blade. To my knowledge, it is the smallest X-Acto blade money can buy. Let me know if there's any smaller ones, because I would like to have some. So I'm just going to be grinding down and carving down around this nub and trying to get more to hook to. Looks like there might be more. Oh yeah, baby. Okay, so that is much more reasonable to hook to. We've now got like this humongous thing that we can solder to instead of this tiny little nub. So I'll clean this up just a little bit so we can see it just a smidgen better. All right, now because I am going to be using this end of that cap as a mounting point, I need to get this little bit of glue out of the way. Yeah, let this be a lesson in pry tools. I know a lot of people criticize my use of my metal pry tool for disconnecting stuff. But, you know, for those people, I've got to wonder if they're so worried about my pry tool being metal and conductive, like, why aren't you disconnecting the battery? Like, disconnect the battery, then you don't have to worry about using a metal pry tool. So we've got this cleaned up. I'm going to grab some 44 gauge copper wire, which is about the size of my hair. So the wire I'm about to use, this is actually enamel coated. It's like magnet wire. It has an insulated coating on it. So what I'm going to do is actually burn that coating off of the wire and also tin it with leaded solder at the same time. I'm just going to use a blob of solder like that. And because I don't like that that still looks a little grungy, I'm going to do this once more. So a little flux on the wire, a little bead of leaded solder, like that. All right, so now we have a nicely tinned piece of 44 gauge copper wire that is extremely difficult to focus on. And now it's time for the fun part. We got to get this down in there and solder it to that little nub that I cleaned off. And to do that, let's just get us some flux down in there. That ought to do it. So we'll just get this down in there. I'm going to tack it on. Actually, let's tin that little nub first if we can. Good enough. All right, so that's got it somewhat tacked on, and now I'm going to switch and grab a pair of tweezers to grab it with. Okay, we'll hold on to it probably right about there and see if I can solder that on there just a little bit better. Let's get a little more flux on there. My nerves are jittering on me some because I know everybody's watching. And if you squeeze this wire too tight, it'll cut it. Oh yeah, that's beautiful. We're gonna stop right there. All right, so we've got a nicely soldered but slightly crooked wire. That's gonna be fine. We'll fix that in a minute. And now I need to get all that flux out of the way. Not much wiping, more just a dabbing going on here, because if we wipe it, it's going to break it for sure. Don't worry, we're going to make this strong here in a minute. Oh yeah, there we crusted over white and dry. Now, it is time for my most favorite part of this repair. First, I'm going to cut this off though, so that I don't accidentally catch my hand on the spool, which, as you can imagine, will cause chaos. And if I can cut it and pull a little at the same time, it'll help straighten that wire. All right, so now we got our spool cut loose, and I don't have to worry about yanking what I just did off of the board with force, which is, you can imagine, is ugly. It is time for cement in a microscopic world. This is green UV mask. This works wonders. So I will take and just put a little dot of this and fill the hole with it. And I'm actually using the tip of a toothpick as a paint bucket. All right, so we're just going to fill this hole up now with green UV mask, and we're going to cement that wire down inside of the board. And now we can use a bright UV lamp and cure that right on up. So now that I have that all cured up, I can now take and form us a nice brand spanking new pad. Now, since I am going to be shifting that component just a little bit more toward the capacitor, I'm also going to shift the new pad that way. So to make us a new pad here, I'm just going to take and coil this wire up as tight as I can get it. That wire might actually be a little bit long. Let's just see what happens. This has to be the tiniest rolled up hose known to man. Okay, we're just going to spin that right on around. Now normally I would roll this all the way down into the pad, but I want to shift it a tiny bit that way, you know, closer to that cap, because we're not going to sit this component directly back on this pad. It's actually going to get shifted just slightly up towards that capacitor right there. So I think I'm actually just going to go ahead and stop right there. And with our nice little snaky coil in place, it's time for a little bit more UV mask. And I am nitpicking here just a smidgen over what this little spot here is, but it is just a spot. It's not actually, oops, not crushed yet. All right, so that's actually going to be fine. We're going to leave that just like it is. And now one more time, a blob of mask on it. Just like that. So with that all cured up, it's time to prepare it to receive a brand spanking new component. And to do that, I'm just going to scratch off this one little bit of a spot here that we're actually going to solder to. And I'm going to leave the rest cemented down in the board. All right, so one side of our new component, it's going to solder right there. And then the other side of the component is just going to solder directly to the side of that cap. That's what I'm going to do with that. All right. Let's just get a tiny bit of solder on there. We're going to tin that with some leaded. Like that, will do just fine. And now take a brand spanking new 240/300 milliamp conductor. And yes, I'm not exactly sure which of it is because I wrote both on this strip. It says 240/300. Like, okay. All right, and this will go right down in here, right there, where the old one, almost where the old one used to be. Oh, I almost didn't shift it far enough. Dang it. That's all right. We can probably just fill that in with solder, right? Everything's going to be just fine. All right, so we'll grab a hold of this right there. And we need that to solder down in there, right there. Okay, here we go. One side of it almost done. And we need to just kind of get a big old blob of solder on the other side. That's what we're going to do about this minor size discrepancy. And then we'll just have everybody close their eyes and pretend like this didn't happen. Oof, way too much solder. Yep. Let's just go ahead and take that little blob off the connector. And again, just pretend like nobody's seen that. Ugh. By the way, if you've been watching this long and you've made it this far into the video, you might as well just go ahead and click subscribe because I'm going to continue posting stuff like this. All right, here we go. No, it came off. All right, let's just try this once more. Let's just get us a big old blob of solder over here. Like that. That's perfect. Just absolutely perfect. Let's just get us one more. conductor that's going to sit right in there just like that. Now, instead of me trying to use my slightly jittery nerves today to solder this on with tweezers and an iron, I'm just going to blast this on here with hot air real quick. And for everybody who's cringing over the use of hot air right here, just remember, I have significantly lowered the melting point of all of this alloy. So everything that I've just done here will melt significantly lower than anything left on the board. So this will actually be reasonably safe. Almost up to temp. There we go. Let's get a little bit of flux on here and make this flow just a smidgen better. And I'm probably also going to go ahead and bump the bottom part of that cap with an iron to add a little bit more solder. I just love using hot air for doing stuff like this. I got lots more solder down here, like that. And because I want this to float nice and pretty and give us a strong joint, like right now we could probably stop and it would be okay, but I don't want this thing to come loose when it's dropped or the next time it gets touched with a pry tool. I want it to be pretty strong. Okay, right about the time it starts to burn the fingers through my gloves, that's where we need to be. Oh yeah, that is beautiful. Absolutely beautiful. And we're going to go ahead and just probably stop right there. I don't like how grungy the solder is between these two components, but that's going to be okay. I'm going to hit it once more. Oh yeah. Much better. Much better. Very strong. All right, let's clean this up with some alcohol. Okie dokie. Now, before anybody laughs at my little bit of a struggle there, this is the sharpest toothpick money can buy, and this is the size of what it is that I just replaced. There is the very tip of a toothpick. You could literally fit 2 of those on the tip of this toothpick. So now that I've got that soldered on into place, I'm going to grab and I'm going to check diode mode readings out at the connector, and I just want to make sure we get like a 0.4 or a point something and not an open line. A 0.64, which I'm going to take that as an acceptable reading. In this case, anything other than an open line, I'll take it. Now the last thing I'm going to do before putting this phone back together is cement this whole project down using some green UV mask. And this will help basically nothing. I just do this because this area is normally coated in this rubbery glue. I guess it might help the next guy that does a screen replacement if they decide to come along and rake a pry tool across this. So yeah, we're just going to cement this all down real good. This will give it some structure as long as I build it up a little on the sides. I also want to cover it up so that it's not just like open conductor. And you know, this was not all covered before, so all right, I'm going to call that good, and again, cure that up with UV mask. That will be the last time using the UV mask during this repair. All right, so here we go. I'm going to connect the charger. We jump straight to 3/4 of an amp, 800 milliamps, 1 amp. Come on, baby. No image. What do you think the odds of me having grabbed a bad screen are? So here we go. I've got the customer screen hooked up to it. I'm going to connect the charger. We are drawing 3/4 of an amp, 1 amp, and no image on the screen. Isn't that lovely? Why did I cement that into the board? All right, so going back under the microscope, I need to make sure we have something other than open line here. Okay. Well, perhaps that means my connection down inside the board popped loose, which I really have a hard time believing that. So let's just scratch off this side of this inductor. Okay, and I want to see if I still get open line there. We're getting nothing there. No way, no two ways about it. Am I at least getting continuity between the connector? Yes. So we are getting a connection all the way through that. Now it's time to have a look at the bottom of the board. So I'm going to peel this little sticker off of here. And right down here at the bottom, we had a row of capacitors. All right, so I'm getting a 0.61 there. So either there is a break inside of the board, or my jumper to that little via became disconnected. So what I'm going to do now is I'm going to replace this with a wire. Let's see, where can we get our wire through? So we've got some nice big old holes open right there. I'm actually going to go for that. Dude, am I really? I think I'm going to have to go back and watch my video to see where I laid that little spool of wire. Aha! All right, so to make this happen, let me just find the best spot. You know, if I could get farther out toward the edge here, that would make me happier. Yeah, let's just go through. Right about there. You see that? You guys thought you were watching a micro soldering channel, but it's actually a sewing channel. All right, so this wire, we're going to have it come through here. Around the edge of the board. And solder on right there. Just like that. All right, let's just get some flux down in there. Yes, I am using a toothpick to apply that. A little blob of solder. Let's see if we can do this without taking that component off the board, shall we? Okay. Now with that tacked in place, I can get a hold of it with some tweezers and guide it just a little better. Really important not to squeeze this wire with tweezers, which I believe I just did, so I'm going to go ahead and take that loose and bring through more wire. Okay, there we go. Yeah, when you squeeze this wire with tweezers, it breaks it, and that might actually be what happened to my first attempt. Okay, so instead of holding it where we need it, I'm going to hold it out here and see if we can burn and solder it at the same exact time. All right, so here we go, final attempt. Just go ahead and tack this wire on there. We're going to burn the coating off of it and solder it at the same time. Marvelous. We're going to leave that just like it is. Now the other side of that wire, I might be able to just get it down in there maybe. Oh yeah, it fits. Make a turn across here. And then solder it right there. That's what we're going to do. Okay. Should have just done this in the first place, huh? That's okay. Okay, so we'll burn the coating off the wire. And solder it on there just like that. Whew. All right. Do you think we're going to get an image this time? Let me ask you this. Do you think I should test it before I slather everything up with green UV mask? So this time, I'm going to test to see if we get an image, then finish this repair. I'm going to go ahead and use my iPhone 7 screen like any responsible tech would do. I'm going to connect a charger and 1, 2, 3. Any moment. 1 amp of current. What do you think the chances of my iPhone 7 screen being bad are? All right, here we go. Drum roll, please. I've got the customer screen hooked up to it. Now I'm going to connect a charger. 400 milliamps, 500 milliamps. Apple logo. All that work connecting to that via down inside the board. And all I had to do was run a jumper anyways. All right, I'm going to let this thing boot all the way up. I'm going to make sure that, it says, iPhone unavailable, try again in 8 hours. This happens a lot of times from people, they know that it's powered up, they can sense that touch is working, and they are trying to blindly make it through the trust prompts so that they can get a backup. And yeah, that's really ugly. So I'm going to go ahead now and slide the power off, assuming touch is working. It is. All right, so I've got the flux all cleaned up, and now it's time to get this thing locked onto the board so that it's not all floppy. And also I would like to insulate it farther from the conductors that it's running next to. In fact, I'm going to pick that up out of there a little. Yeah, I have that sit right there. Tack it right down to the top of this chip. Get some goop right here in the crack. You don't want to get this stuff too thick, like way down in the crack, because it won't cure where the sun don't shine. Right there and there. Let's see. I'd like to move this wire over just a smidgen so that it doesn't wind up pinned under a standoff post. What is it with the iPhone SEs and winded up having wires running all over the place? All right, and just because I'm a lunatic, I'm going to go ahead and put a little blob right here on top of what's probably like an audio amplifier. All right, there we go. That's going to have that wire tacked down all over the place on this side so it's not flopping. Let's get that cured up. Oh, and also, I think it's pretty safe to throw away that iPhone 7 screen now. All right, so that has that side cured up and locked into place. There we go, good as new. And most of all, I don't want it to flop around here on the corners. We don't want it sitting in, like, you know, over time chewing through anything that's going to cause it to touch something that it's not supposed to. And again, this is magnet wire, so even if it does wind up against something, it's not just going to immediately short. We just don't want it to, you know, rub over time. Now, I used way too much UV mask on this, so I'm going to have this sit and cure for a pretty good long while. But at least I know that it is strong, and at least I know we have working image. So cure this up one last time. Oh yeah, baby. It's just like nothing ever happened. Brand spanking new. Electrically, this phone will never know any difference. And if somebody were to open this phone and look at it, like, they're not going to be able to see that wire there unless they look at it really, really, really good. Okie dokie, I've got the board back in the housing. I've got all of the screws, retaining brackets, and whatnot all screwed back in the way they go. I have went through and I've checked to make sure all the screws on the screen assembly are tight, and this thing is hopefully going to have a good day after this. So we'll just go ahead and close this thing right on up. Okie dokie, I've got this phone all the way reassembled and it should be ready to send back to the customer. I'm going to give it one final test and hopefully we still get a Apple logo and a boot. 600 milliamps, 1 amp of charging current, and we have a Apple logo. And this phone is going to be good to go. I am pretty stinking worried about that iPhone unavailable, try again in 8 hours. I'm happy to feel that the home button does click. It's really common for people to accidentally tear the home button flex on the new screen. There's not a whole lot that I can test when it's stuck in iPhone unavailable. About the most that I can do is hold my hand over the screen and make sure that the ambient light sensor is working, and it is. And also, I can look through the holes on the front and see that whoever put together the screen assembly has the proximity sensor lined up properly. So this thing should be completely good to go. That is going to be a happy customer, and also that is going to be the end of this video. So if you like my videos, please give me a thumbs up. Let me know what you think in the comments below. And also, if you like this type of thing, feel free to subscribe. I'll be posting as often as I can. And yeah, that's it for this one, everybody. Have a good day. Thanks for watching.